The percent proportions worksheet that you all had over the weekend. I asked you on Google Classroom and in class and told you to show these 4 items on each problem. So the key thing is writing the percent proportion from the given information. Putting the numbers in the correct place is super duper important. Then the rest of this should be very repetitive, but I really want to see your cross products equal when you cross multiply. And then when you divide both sides of the equation by whatever number is in front of the variable, and that'll be the coefficient. And then when you get your answer, make sure you label it. So the key thing is get your proportions set up to where the left and the right side are set up appropriately. And then cross multiply, divide, and get an answer. I'm going to step through the problems here. I have them kind of blocked out here. Problems 1 and 2, we have pretty straightforward situation here. A student earned a grade of 80% on a math test that had 20 problems. So that 20 problems is how many total problems are on the test. How many problems on this test did this student answer correctly? And it says to round it. If we get a messy number, it typically will tell us to round. Turns out this one doesn't require any rounding at all. So the percent proportion goes pretty straightforward. On the right side, I always want you to put the percent that you're given over 100. That locks in half of the proportion every single time. And then on the other side, we just need to put the number, that other number that we're given, this 20 problems. If this 20 problems was what the student got, this 80% is what the student got, and so they would go in the same place. However, this 20 problems is how many questions are on the test. It's the total number of questions. So this 20 must go down here, and then the unknown, how many problems on the test did the student answer correctly, goes here. I'm just going to call it X, kind of generic, that's fine. So here's my percent proportion, and then every single time I'm going to do one cross product, that's this one, and I always list the one that has the variable in it first. That's not a requirement. I just find people do better doing that one. So 20 times 80 is the other one. I would prefer you not to do this yet, because writing it like this is showing me that you did the cross product correctly. You'll do the arithmetic later, it's not a big deal. And then whatever coefficient is in front of the x, you just divide by that. And so when I divide that, it turns out it works out really nicely. And if we look at it, dividing by 100 is going to cancel out these 2 zeros. 2 times 8 is 16, so we get 16. And we need to label it. How many problems did the student answer correctly? 16 problems. Correct. And we could do that quick little check. We could say, okay, 16 out of 20. 16 out of 20. You might have noticed that I could just take 20 and multiply it by 5 to get 100. So that is a quick little check I could do. It's fairly obviously going to work out. 16 out of 20 is 80%. So moving on to question 2. There are 36 carpenters in a crew. On a certain day, 29 were present. So 29 is how many show up out of the 36 in the crew. And it asks what percent showed up for work. So I'm immediately going to start writing my proportion. I always put the percent over 100 as a starting point. So percent over 100 immediately. And then I just have to figure out which way these numbers go over here. The percent is what I'm asked for. What percent? I don't know what that is, so I'm going to call it P. And now the percent are the percent that showed up for work, and it said that 29 were present. That means they were there, they showed up. So that 29 is the same information as this percent is going to be. It's the part of the crew that showed up. And then the whole crew is 36. So part that showed up out of the whole crew is some percent out of 100. And now I'm going to cross multiply and divide repetitively. So 36p equals 29 times 100, and I'll divide by 36. I'm always going to go through this part of it pretty quick because it should be repetitive. We've done quite a bit of those already. If it's challenging for you there, just pause the video and see if you can work it through without my assistance there. So I'm going to just type this in, 29 times 100 divided by 36. and I get a repeating decimal. I get 80.5, and it's repeating, and that's the percent showed up. They did tell me to round it. It said round to the nearest tenth, so that's one decimal place. So if you think about it, if it's a repeating 5, there's a 5 right after this 5, so this 5 here is going to round up. So the official final answer is 80.6% because I rounded to the 10th place. Now, if you have everything worked out perfectly and miss it just because of rounding, I'm not overly concerned about that, but I would like for you to be able to round appropriately. I'm going to move on. I'm going to pick a brighter color here, maybe something that'll show up really bright. So let's move on to question 3. So question 3, we have a metal bar weighs 8.15 ounces. 93% of the bar is silver. So this 93% is silver. This 8.15 ounces is the whole metal bar. It is not just the silver part, it's the whole bar. And the question is, how many ounces of silver are in the bar? So when I set up my proportion, yeah, just throw that percent over 100 every time. However, we need to know that that 93 is the silver part. So this numerator over here will be the silver part. And that's the question. How many ounces of silver? So I don't know how many ounces of silver. I'm just going to call it X. And then this metal bar weighs 8.15 ounces. That is the total weight of the bar, so 8.15. And so now I'm ready to cross multiply and divide. Again, I always pick the one that has a variable. 100x is equal to 93 times 8.15. And then I'll divide by 100. Divide by 100. And I do that on both sides so I can cancel it there on the variable side. And now it's just calculator arithmetic. 93 times 8.15 divided by 100. And I get 7.5795. However, they did tell me to round to the thousandth. So if we think about our place value, this is tenths, this is hundredths, this is thousandths. So the thousandths is the third place over. So there's a 5 to the right of this 9, which bumps this 9 up to a 10, which is a 0 with this bumped up by 1. So it's 7.580. And I'm going to label that ounces of silver. And you may be thinking, why can't I just drop off that 0? And technically it's the same value, but if you drop off that 0, you're going to, or anybody would assume that you rounded to 2 decimal places. So putting that 0 means we know it is to the thousandths place, a 0 there. Just like if I told you I weighed 180 pounds, or I told you I weighed 180.000 pounds, those extra zeros mean it was measured very precisely. So that's not super relevant on this problem, but I do think you should have that 0 there. In general, if it says to round to the thousandths, then you should have a thousandths place there. Whatever place they say to round to, you should have that place in your answer. So let's move on to number 4. Number 4, a woman put $580 into a savings account for 1 year. The rate of interest was 6.5%. And then how much was the interest? This is an interest rate, and they ask me for the interest. So keep that in mind when we're setting up our proportion here. Always put the percent over 100. I'm going to be using a calculator that doesn't have a fraction button on it, so I'm just going to use 6.5 instead of 6.5. Doesn't really matter. And then I always put that over 100. This is an interest rate, and they ask me how much interest. So I don't know how much interest. This is an interest rate, so this is the interest in dollars, and I don't know what that is. I'm going to call it X. And that means this 580 is the whole part. It's the money that's put in the account that's earning that interest. So it is the whole amount before they add in that interest that you've earned. So now I'm going to cross multiply and divide, same as before. So 100x is equal to 6.5 times 580. And I'm going to divide by 100 because that's the coefficient of x. And it says to round to the nearest cent. That's because we're dealing with dollars and cents, so it makes sense to round it to 2 decimal places. So let's see what we get. 6.5 times 580 divided by 100. And turns out I don't need to round anything. I get 37.7, but this is the amount of interest, and it's a dollar amount. Nobody should say $37.7. I'm going to tack a 0 on there. This is $37.70 in interest. So assuming nothing was taken out of that at the end of the time, they will put that money in there. You're earning interest because the bank is using your money. And so interest is just payment for using money. So that is number 4. Let's move on to number 5. Number 5, a student answered 86 problems on a test correctly. So that's what the student actually got correct. And they received a 98%. So that 86 problems earned them a 98%. How many problems were on the test if all the problems were with the same number of points? So I'm going to write my proportion. Again, strongly encourage, write out your percent over 100 immediately. So I'm going to put the 98 out of 100 immediately. And now this 98% is the grade they earned by getting 86 problems correct. This 86 is the ones that they got correct, and this 98 is the percent that they got correct. So the 86 and the 98 need to go in the same position. So this side has the percent information, and this one has the problems. And the question is asking how many problems were on the test. That is the whole number of problems. This person got 86 right out of a certain number, and I don't know what that is. I'm going to call it X. I'm using X just about every time unless it's a percent. So now I'm ready to go. I'm ready to do my cross, multiply, and divide. So I'm going to do my cross products. 98X is equal to 86 times 100. And divide by 98. Divide by 98. I get 86 times 100 divided by 98. And I get 87.75, something or other, 87.75, and it keeps going. But it says to round to the whole number, and if you think about it, it makes sense. This is the number of problems on a test, so this should not be a decimal number. So this is going to round to 88, so there's 88 problems on the test. And this student got 86 out of those 88 correct, and then that percent, it probably doesn't work out exactly, but it rounds to 98%, so they got a 98 on that test. So 88 problems on that test. Question 6. Manuel found a wrecked Trans Am that he could fix. He bought the car for 65% of the original price of $7,200. And what did he pay for the car? And it's a dollar and cents thing, so we're going to round to the dollar since it's a big sort of amount. So first thing I do, percent over 100 immediately. And then I really have a 50% chance of randomly guessing. But let's think about it. It's 65% is what he bought the car for. And they are asking, what did he pay for the car? So this 65% is what he bought the car for. And we're asked, what did he buy the car for? So I don't know what he bought it for. But it is 65% of the whole original price of the $7,200. So this total down here is $7,200. So what he paid out of the $7,200 original price is told to us as 65% out of 100. So I'm ready to cross multiply and divide. So there are my two cross products. 100x is equal to 65 times 7,200. And divide by 100. And if you look at it, we are dividing by 100, and that 7,200 has 2 zeros on it. So really, it's just 65 times 72, and I get 4,680. And this is a dollar amount. I don't need to round it. It's already a whole number, but I do need to put a dollar sign. So that's what he paid for the car. So Manuel paid $4,680, and he got that good deal because it was wrecked. and he could fix it, so he paid a cheaper rate there. So we have one more on this screen. I'm going to do a little scrolling here. So number 7, Pamela bought an electric drill at 85% of the regular price. She paid $32.89 for the drill. What was the regular price? So every single time, put percent over 100, so 85 over 100. However, let's think about what that 85 is. That's 85% because it was on sale. It's less than 100%, so it's on sale. It's 85% of 100%. And then if you think about it, Pamela bought it at 85% and she paid $32.89. So this $32.89 is the sale price. It's what she paid. So $32.89 must go in the same position as the 85% because she bought it on sale and that's what she bought it for. So this is the percent and this is the dollar amount over here. What we don't know is the full price, and that's the regular price that they're asking us. So I'm just going to call that X. And now I'm ready to go. $32.89 on sale out of some full price is 85% out of 100. And so cross multiply and divide. And so I'm going to get 85x is equal to 32.89 times 100. And then divide by 85. It does say to round it to the nearest cent, so that means I'm going to round it to 2 decimal places, so we'll have dollars and cents. So 32.89 times 100 divided by 85. And let's see, I got 38.69 if I round it. 38.69. 32.89 times 100 divided by 85. Yep. And this is the dollar amount, and that's the regular price. So the regular price was $38.69, but because it was on sale for 85%, they would probably have advertised that as 15% off. That's typically how they do that. But it shouldn't be a surprise that she paid less than $38.69. If you had put these in the wrong place, then the regular price would have been lower than the sale price, and that hopefully wouldn't have made sense to you. So there is number 7 all worked out. So let's move on to numbers 8 and 9. So number 8, a crew is made up of 8 men and the rest are women. 66 2/3% of the crew are men. How many people are in the crew? So the percent is kind of a messy 66 2/3, and it's always out of 100. So there we go. It's locked in. This 66 2/3 of the crew are men, and it says there are 8 men. So this percent is the percent that are men, and this 8 is the number that are men. So they're both representing the men, so they go in the same position. And then it says 66 2/3% of the crew. So this is 100% of the crew. This is the number in the crew, and I don't know what that is. And in fact, that's what they ask, how many people are in the crew. So if I use an X there, then I have my cross products, and I'm ready to go. So I'm going to go 66 2/3 times X is equal to 8 times 100. And then I'm going to divide by 66 2/3. Now, if you have a fraction button on your calculator, you're welcome to use that. This work here is showing me the arithmetic you're doing. The manual showing of that arithmetic I'm not overly interested in. The calculator I'm using doesn't have a fraction button. I could go up into a little menu, but I'm just going to go 8 times 100 and then divide by 66. And then I know that 2/3 is a repeating 6. So I'm going to go point and then just a bunch of 6s until I get a little tired of that. And when I hit enter, I get 12. So what does that 12 mean? Well, that's how many people are in the crew. There's 12 people in the crew. And 8 of them are men. It said there were 8. So 8 out of 12 is 66 2/3. And if you think about it, 8 out of 12 does reduce. You could divide them both by 4s and get 2/3. And you may recognize 2/3 as being 66 2/3%. So let's move on to question 9. Ben earns $12,800 a year. About 15% is taken out for taxes. How much is taken out for taxes? So when I write my proportion, I throw the percent over 100 immediately, but I think about what is that 15%? It is 15% is taxes. And they want to know how much is taken out for taxes. So this is the percent that's taken out. They want to know the amount, the dollar amount that's taken out. I don't know what that is, so I'm going to call it X. And that tax is 15% of what he earns. So this $12,800 is the total amount that's earned. So some amount of taxes on $12,800 is 15% out of 100. So I'm going to cross multiply and divide. And so I get 100x is equal to 15 times 12,800. And when I divide by 100, this is going to divide nicely because I see there's 2 zeros there. When I divide by 100, those are going to go away. So 15 times 12,800 divided by 100, and I get 1,920, which is the dollar amount in taxes. So he's going to have, Ben's going to have $1,920 of tax taken out of his check to fund the government. I'm not going to get into that. So Ben earns $12,800, pays 15% in taxes, and 15% of that $12,800 ends up being $1,920. So let's move on to the last page. We have 3 more problems. So these last 3, well, the last 2, there's a little extra step we're going to have to do. And there's actually 2 different ways you could attack it. I'll probably work it out both ways. So number 10 is just like any of them, though. It's 11 and 12 that have an extra step that we'll have to deal with. So number 10, at a sale, shirts were sold for $15 each. This price, that 15, this $15 was 80% of the original price. And they want to know what is the original price. So when I write my proportion and I put that 80% over 100 as a very first step, I need to think that 80% is of the original price. It's what led to that $15. This $15 is 80% of the original price. So this $15 goes in the same position in the proportion as the 80%, because this price, referring to the 15, was 80% of the original price. So $15 out of some original price, don't know what it is 80% out of 100. So 15 out of something is 80% out of 100. So when I cross multiply, I'm going to get 80x is equal to 15 times 100 and divide by 80. And now it's just calculator button pushing. 15 times 100 divided by 80. And I get 18.75. It doesn't say anything about rounding, so I'm not going to round it. It's 18.75, and this was the original price. So this is a dollar amount. So the original price was $18.75, but because it was on sale, they were selling them for $15 each. So that is the last of the standard ones. 11 and 12 are a little bit extra, but not really challenging. It's just you have to be careful. Both sides of the proportion have to be saying the same thing. So keep that in mind when we go to setup number 11. There are 32 students in a class. 9 of those students are women. And the question is, what percent are men? This 9 is women, but they want to know the percent that are men. So we have 2 routes we can go. We can use this 9 and the fact that there's 32 students in the class, and we can calculate how many men there are. So then my proportion is going to be men out of total is percent out of total, or percent out of 100. That's one option, so let's set it up that way. To calculate the number of men, I would take 32 students minus 9 women and get that there's 23 men. So if I set up my proportion, men over total is percent out of 100. The percent, I don't know. I'm going to call that P out of 100. And then I do men over total. So the men is 23, and the total is the 32. 23 out of 32 students are the men. So now when I cross multiply and divide, I should get the percent that are men. So I'm going to do that real quick. 32P is equal to 23 times 100. And I'll divide by the 32. And when I divide by 32, let's see what I get here. It says round to the 10th. That's one decimal place. So 23 times 100 divided by 32. And I get 71.9 if I round. 71.9%. And that is men. How do I know it's men? Because this is the number of men. I put the number of men, so this is the percent of men. Let's take a look at it and see, what if I didn't do this subtraction over here? What if I put the 9 over the 32 and put percent over 100? Let's see what happens here. I get 32 times P is 9 times 100, and then divide by 32. And when I do that arithmetic here, 9 times 100 divided by 32, I get 28.1. That is the percent, but since this 9 is women, this is the percent that are women. If we are logical, we should be able to go from here to here. Women and men put together is going to be 100%. So if I did this, this is the women percent. I could just take 100 minus 28.1, and that would have gotten me the same answer. The answer has to be the 71.9 because that represents 23 out of 32. The 28.1% is a fine answer if they had asked for the percent that are women, but they didn't. They asked for the percent that are men. So what this problem is showing us is that this number, its meaning has to match the meaning of this percent. So if they ask for the percent of men, then I need men here. If I put the 9 there, since this is women, then this percent is women. And if we're logical, we can get to the men from there, but I can't stop with that. If the percent of the students, it has to be 71.9% men. The same thing occurs on number 12. On number 12, the Royals softball team played 75 games and won 55. And it wants to know, what percent did they lose? You can't use the 55 and find the percent that's losing. I need to put the losses. How many did they lose out of the games that they played? Will be a percent out of 100. So I'm only going to work it this way because I really think you should try to get it to match up initially. I want to answer the question, what percent of the games did they lose? I don't know. But then if this is the percent that they lose, then this has to be the number that they lose. The number that they lose. So 75 games played and they won 55 of them. So if I come over here, 75 minus 55 is 20. So they lost 20 games. So this 20 is what has to go here. If this is the percent they lose, this is the number that they lose. And then this is the total number of games, which was the 75. So 20 out of 75 is some percent of losing out of 100. And now I'm going to cross multiply and divide. So if I do that, I get 75p is equal to 20 times 100. Divide by 75, divide by 75. And I get 20 times 100 divided by 75. And I get a repeating, it says to round to the 10th, so that is 26. And it's a repeating 6, so that's going to round to a 7. So what percent of the games did they lose? They lost 26.7% of their games. if you didn't do that subtraction here, if you put 55 here, it wouldn't be the end of the world as long as you understood the percent that you would get there is the winning percent because they won 55. So if you put 55 over 75, then this percent over 100, this is going to be the winning percent. The win percent, which if you know what percent they won, then you can calculate what percent they lost. So you can still get there, but you got to remember to do that. So either you subtract ahead of time or you can subtract after the fact. Either way should work out just fine. So there are those 12 problems worked out using the percent proportion. Each one I showed my proportion, I showed my cross products, I showed my dividing, and then I got an answer and I made sure I labeled it. So if you have any further questions, make sure you ask on either Google Classroom or talk to me in class. That's it.